Hello everyone. In the topic subsets, we'll see few of the questions which are related, and the subsets definition is already given. If two sets are given, if every element of A is an element of set B, then A is called as subset of B and it is shown with A subset to B. So this is a general example, it is already explained, and we'll see which symbol can be used, subset, not subset. So four sets are given. First one is pi, that is empty set. A is equals to 1 comma 3, B is equals to 159, C is equals to 13579. So these are the sets which are given. Now we'll see which symbol can be used in between. And pi is a set which is a subset to any set, then pi will be subset to set B. You keep it aside. Then A and B. A and B, look at the elements 1 comma 3, 159. Only 1 is the common element for both, but 3 is not. 3 is not present in B. Then A is not subset to B. And coming to the third one, A and C, A 1 comma 3, C 13579. So 1 comma 3 are present in C, so it can be taken A is subset to C. And comparing B and C, 159, 159. So all the elements of B are elements of C also. Then B is subset to C. So these are the things for the first question. Now we'll see the second one. Question is given, let ABC be three sets. If A belongs to B, B subset to C, is it true that A is subset to C? If not, give an example. So here it is mentioned A is belongs to B. The meaning will be A is an element of set B. A is an element of set B and B subset to C. B is a set subset to set C. Now we'll see. First of all, I'm taking A is equals to 1. It has one set. A is equals to 1 as a set. Then B is equals to taking this set 1 in the set B, 1, set 1, set 1. Now it is an element, comma 2 comma 3. So A is equals to 1 and B is equals to set of set 1. Set 1 is going to be element now. 2 and 3 are also going to be elements. And take C is equals to, C is a set, taking 2, 3, 4. Now we'll see whether all the conditions are getting satisfied or not. A is belongs to B. Yes, A is the set. A is a set here, and which is exactly belongs to B. Then A belongs to B is getting satisfied. Yes, it is satisfied. And whether B is subset to C, B is, now the set C has changed now. Set 1 is an element of C. 2, 3, 4. These 4 elements are taken now. Now see, B is subset to C. 2, 3 are present here. Elements of 2, 3. Elements of B, 2, 3 are present here. And set 1 is also present in set 1. Present as set 1 in set C. Yes, B can be taken as B is subset to C. And after taking that, now see what is asking, is it true that A is subset to C? A is the set, A is subset to C. To say A is subset to C, here A is the set, A is equals to 1 is the set, but it is an element of C. So it is an element of C, meaning is A is already inside of C. Then A is belongs to C. So this implies I can take A belongs to C, it can be, but but is asking that A is subset to C. A is belongs to C, but A is not subset to C. A is not subset to C. Coming to the next subtopic, subsets of set of real numbers. First of all, set of real numbers we consider, so it is taken here as R, and starting from here, so first of all, in that real numbers, two things are to be taken. First one is q is nothing but rational numbers. Rational numbers will be of the form p by q not equals to 0, p comma q both belongs to z. So in rationals, in reals, rationals is a subset, and r minus q is nothing but irrationals. Then those elements which are not rationals, those are going to be irrationals. So in the real part, either elements are going to be, either numbers are going to be rational or irrational. That's it. Now coming to we'll see from here. So first of all, we already defined, we already seen rational and irrationals. Now natural numbers are taken like 1 2 3 and so on elements. Natural numbers are 1 2 3 and so on. And w, natural numbers will be the subset of w is whole numbers, only 0 will be added extra. 0 1 2 3 and so on elements are going to be considered as set w. And to this w, to make it as z, so we will make it as -3 -2 -1 and so on terms. Negative integers, 0 and positive integers, all these terms will be included, can be considered as z now. And after taking the integers, the numbers which are of the form p by q like 2 by 3 7 by 5 and so on, those terms are going to be included. Then it will become rationals. So it will become rationals. So simply we can write n is subset to whole numbers is subset to z, z is subset to rationals are subset to reals. And one more, r minus q, that is irrational numbers, are also going to be subset to real numbers. Now coming to the next subtopic, intervals as subsets of R. Intervals as subsets of R. If you consider real number system, so real number system can be taken 0 1 2 3 and so on to infinity, -1 -2 -3 and so on to minus infinity. Now this is your generally real number system. And if you wanted to write, if you wanted to take some part of the real number system, then it can be taken in this manner, like 2 3 you consider as 2 to 3 you will take closed interval a comma b. Closed interval a comma b, a and b both should be included, and as well as middle numbers are also going to be included. So if 2 to 3 if I wanted to consider, like 2 to 3 if I wanted to consider, now we'll take one more 2 and 3. So these 2 to 3, these parts are going to be like 2 less than or equals to x less than or equals to 3. So this part is going to be written, and 2 3 both are included, and this middle one also going to be included, like 2.5 2.7 2.9 and so on terms, so on numbers will be included in the closed intervals, including 2 and 3 also. And semi-open or semi-closed intervals, like a is open, this bracket is indicating for open bracket, this is closed one. Open means not included, a less than x, a is not included in that. And b is closed, b is taken, b is considered. Then a less than x less than or equals to b, a is not included but b is included. So taking 2 to 3, 2 to 3, 2 is not included and 3 is included. So 2 less than x less than or equals to 3. So 2 is not included but 3 is included, and the middle one also going to be included, like 2.1, 2.2, 2.3 and so on terms. So this can be taken as 2 comma 3, 2 is open, 3 is closed, and in this case 2 comma 3, 2 is closed and 2 is closed and 3 is also closed, and a is open but b is closed. A is included, a less than or equals to x, but b is not included. So here we'll see 2 to 3, 2 is closed, 2 is closed, 3 is open, 2 less than or equals to x less than 3. So this is, it can be considered, and if you wanted to draw the diagram like 2 to 3, 2 is included but 3 is not included, these parts are going to be taken. And the last one, open a and b, open interval, this is called open interval, this is called closed interval, and both a and b are not included, both a and b are not included. 2 comma 3 open interval is nothing but 2 less than x less than 3, and the diagram will be in this manner. So 2 to 3, 2 is not included and 3 is also not included, the middle ones will be considered. So this way you can come to understand intervals as subsets of R. Coming to the next important topic, next important subtopic, definition of the power set. Power set, the definition is set of all subsets of a set. If you consider any set, then set of all subsets of that particular set is called as power set. And taking the example a is equals to 1 2 3, then what are the subsets of set A? First of all, pi can be considered as subset to any. So pi is a subset, pi is a subset to any set. And the second one, taking that element 1 only, taking that element 1 in the set, it is subset to set A. And next, taking the element 2 and writing it as a set, writing it as a set, taking set 1, set 2 and set 3, element 1 as a set, element 2 as a set, element 3 as a set, these three are subset to A. Next, taking two elements 1 comma 2 as a set, it is subset to A. Next, 1 comma 3 is also subset to A, and next one 2 comma 3 is also subset to A, and last one, taking 3 elements at a time. So taking 3 elements at a time, so taking 1 2 3 as a set. Now taking all this in one, taking all this in